In this lesson, we're going to talk about the discriminant. And it is really just a piece within the quadratic formula. It is the piece underneath the radical. So it's just the b squared minus 4ac. That's known as the discriminant. And it's actually going to give you a little bit of an indication of what kinds of and what types of solutions and how many you're going to get from your quadratic formula, and the number of x-intercepts. There's a visual connection to it as well. So this is the quadratic formula. The discriminant is just b squared minus 4ac. All right, no square root attached to it, so just the inside value before you square root it. And there's going to be three situations to it. So there's three different kinds of values that this b squared minus 4ac can become. So the first situation is that if b squared minus 4ac is greater than 0, okay, so that means that this is something that you can square root. Doesn't matter if it's a perfect square or not. That you're going to be able to add that square root value to this, and you're going to subtract the square root value from it. So that's going to give you two real solutions. All right, that also has a visual connection to it. That visually, your quadratic has a parabola shape of some kind. And if you have two real solutions, that also means you have two x-intercepts. So every time you get two real solutions, whether they're decimals, whether they worked out perfect as perfect squares, doesn't matter. You're going to get two x-intercepts associated with just that value being greater than 0. All right, so that's one situation. A second situation is if you do the math on the b squared minus 4ac and it equals 0, so that means you're adding 0, because the square root of 0 is 0, and you're subtracting 0. It's really not going to change this negative b divided by 2a. So you're adding 0 and subtracting 0. It's going to leave you with just one real solution. It's going to leave you with the same thing. So it's going to be a repeat. So one real solution. So visually, one real solution means you're going to have just one x-intercept. So there's the correlation between the visual and what you're going to get as far as solutions go. Third situation is if you do the b squared minus 4ac and it is less than 0. Less than 0 is a negative number. That means you have a negative inside your square root, which causes you to have two imaginary solutions. Now there's solutions. You could take the values back in, plug it into the original, and it would work. But just that little piece is telling you that they're going to be imaginaries, and there's something going on with your visual with two imaginaries. Imaginaries don't show up on this type of a graph. So visually, your graph is going to have no x-intercepts. Okay, and all of these graphs could be reflected the other direction. So it could be down here, not crossing the x-axis. Could be above, not crossing the x-axis. This one, we could be down and hitting the x-axis one time from below. But in general, that's kind of the look to them. So let's do a couple examples. So we're going to determine the type, common number of solutions, and number of x-intercepts. So number one, we'll have this sort of a quadratic, 4x squared minus x plus 4 equals 0. And we're not looking to actually solve it, we're just talking about what kinds of solutions, what might the graph look like in general. So we are talking about b squared minus 4ac. That's describing what kinds of solutions and what number, how many x-intercepts we have. So that's all we have to do. We don't have to actually solve it. You're not asked to solve it, you're just determining the types of solutions. So b squared is going to be, this is your b value, this is your a value. So if you know the standard form for a quadratic, this is your a value, this is your b value, this is your c value. So we have negative 8 squared minus 4 times your a value, which is 4, times your c value, which is 4. And the reason I put parentheses is because we're not just squaring the 8, we're squaring the negative and the 8. So if you don't do that, it's going to leave you with a negative, which is not true because we're squaring a negative. So that's going to get us 64 minus all of that also makes 64. So you get a 0. So 0 means we're going to have one real solution and we're also going to have one x-intercept. So it would look something along those lines. All right, so let's do another. All right, number 2. So number 2 is going to be 6x squared equals 2x minus 5. Now this form doesn't help us. We need to rearrange everything. We need it to be all of the values all on one side and ideally leaving this as a positive. So it's already positive, which means we're going to bump these two pieces over. So 6x squared, if we bump that over, changes its sign. If we bump the 5 over, changes its sign, equals 0. So now we're ready to do the discriminant. So, no different. B squared minus 4ac. And that's going to give us a negative 2 squared minus 4 times a, which is 6, times 5, which is c. Negative 2 squared is 4. I don't have any negatives to cancel out the negative here. So I have 4 times 6, or maybe 6 times 5 is 30. 30 times 4 is 120. That leaves us with negative 116. And I really don't even care about what the value actually is. It's a negative something, which is going to leave us with 2 imaginary solutions. And that means graphically we're going to have no x-intercepts. And that's it. So visually we'd have something along those lines. All right, we'll do one more. So if we have a 10 minus 5x squared equals 6x plus 5. Same thing, I want to rearrange everything. I don't like that being a negative in front of the 5x squared, so I'm going to bump that piece over. So we're going to bump both those pieces over, leaving us with a 0 on that side. That's going to become a 5x squared. The 6x doesn't have another like term to combine with it, but we're going to subtract the 10 over, which the positive 5 and a negative 10 is going to make a negative 5. So we're ready to do our discriminant. So b squared minus 4ac is going to be 6 squared minus 4 times 5, which is a, and negative 5, which is c. So this is 36. We do have a negative times a negative this time, so we're going to be adding those two pieces together. So that's 25 times 4 is 100. That adds up to 136, which means we have 2 real solutions, which corresponds to 2 x-intercepts. All right, and that was introducing the discriminant and how it relates with the quadratic formula and what it looks visually.